Hello students, I'm Vincent Fernandez, your math teacher from Sri Sarvagna Public School. Previous class we have discussed about divisibility test by 5 and 6. So today we are going to learn about divisibility test by 8 and 9. So how are we going to find out whether a given number is completely divisible by 8? So a test for that is available, but this involves actual division, but not the entire number, but only a part of the number. So what part of the number is to be divided? Let us check. So supposing there is a 6-digit, 5-digit, 4-digit type of number, the last three places, that is the hundreds place, tens place and ones place digits are taken and divided by 8. So example for this, 2464. Here 464 is the 3-digit part. So 464, if it is divided by 8, actual division, will we get as a remainder 0? Is it completely divisible? Let us check it out. 464 is divided by 8. 8 5 is 40. So 46 minus 40 is 6. Bringing down 4, we get 64. 8 8s are 64. Remainder is 0. So that means that 464 is completely divisible by 8. That is the reason why we say 2464 is also completely divisible by 8. So let us try another example. Here is a bigger example, which is 6,84,256. It's a 6-digit number. So if it is a bigger number with a more number of digits, it will be quite easy for us to do, because we are only going to divide the last 3 digits. So the last 3 digits are 256. So this 256 is divided by 8. 8 3 is 24. So 25 minus 24 is going to give me 1. Now bring down 6, it becomes 16. 8 2s are 16. So when I am subtracting this, I get a 0 as a remainder. So as you can see from the division, the number 256 is completely divisible by 8. So that means that this 6-digit number, that is 6,84,256, is also completely divisible by 8. So this is the test of divisibility. Of course, if you don't get a remainder 0, that is when you take a 3-digit number, if you are going to divide it by 8 and you don't get the remainder as 0, that means that the test has failed, meaning the whole number is not divisible by 8. Okay? So two examples have been given where the divisibility test is holding good. That does not mean that every number which you find out, which you get, is divisible by 8. So two positive results have been given. Now, test of divisibility by 9. So once we have finished with the test of divisibility by 8, divisibility by 9 is quite easy, because it is same or similar to that of divisibility test by 3. What we did there, we took the digits of the number, added them, and the sum was divided by 3, isn't it? So if it was divisible by 3, then that sum is divisible by 3, then it is completely divisible by 3. The whole number is divisible by 3. Here also, similar way, we add all the digits in the given number. If the sum of those digits is divisible by 9, that's in mind, divisible by 9, not 3. If it is divisible by 9, that means it is a multiple of 9, then this whole number is divisible by 9. So remember this, every number which is divisible by 3 need not be divisible, that is can be divisible by 9. This is not at all possible. So if every number which is divisible by 9, that can be divisible by 3. But all numbers which are divisible by 3 are not divisible by 9. So carefully check out the problem and find whether it is divisible by 9 or not. One example is given to you. 43,623 is the given number. The digits are 4, 3, 6, 2 and 3. Add them. 4 plus 3 plus 6 plus 2 plus 3. When I add them, I get a total to be 18. So if I add this and get the total as 18, now 18, is it in the tables of 9 or is it a multiple of 9? 9 ones, 9, 9 twos are 18. So we have the number 18 in the tables of 9. So it is divisible by 9. It's a multiple of 9. So 18 is divisible by 9. Therefore 43,623, this number is completely divisible by 9. So this is the test of divisibility by 9. So we have covered up to now divisibility test by 2, 3, 4, 5, 6, 8 and 9. So there are a few problems which are given here as assignment. Please try to do them. The first step is this. You have to check here whether they are divisible by 8 and 9. 3,688, 75,348, 63,072, 87,432, 5,58,864. Try to do this. All the best and bye.